Catalysis. A catalyst increases the reaction of a chemical process without being consumed. A catalyzed chemical reaction has a lower energy, E(A), as the difference between the energy of the reactants and the energy of the products is not affected by the presence of a catalyst. As the energy, E(A), is lower, the reaction rate in a catalyzed process is faster than the reaction rate in a non-catalyzed process with the temperature being the same. The presence of a catalyst decreases the height of the energy barrier. Its presence increases the reaction rate of both the forward and the reverse reactions by the same amount. Catalysts can be classified into heterogeneous, homogeneous, and the enzymes. In heterogeneous catalysis, the catalyst is in a different phase from the reactants. The catalyst interacts with one of the reactants in such a way that a chemical bond in the reactant becomes weak and then breaks. The interaction of hydrogen gas with the surface of a metal is an example of a heterogeneous catalysis. The hydrogen-hydrogen bonds break and produce individual adsorbed hydrogen atoms on the surface of the metal. The adsorbed atoms can move on the surface. The two atoms can collide and form a hydrogen gas molecule that can then leave the surface in the reverse process, called desorption. Since the hydrogen bond is broken, the energy barrier for most reactions of hydrogen is substantially lower on the catalyst surface. In homogeneous catalysis, the catalyst is in the same phase as the reactants. The number of collisions between reactants and catalyst is at a maximum because the catalyst is uniformly dispersed throughout the reaction mixture. Many homogeneous catalysts can be used only at relatively low temperatures. Examples of homogeneous catalysis are high-density polyethylene and polypropylene. Enzymes are naturally occurring catalysts in living organisms. Enzymes are protein molecules with a molecular mass of 20,000–100,000 amu. Some are homogeneous catalysts that react in a solution within a cellular compartment of an organism. Others are heterogeneous catalysts embedded within the membranes that separate cells and cellular compartments from their surroundings. The reactant in an enzyme-catalyzed reaction is called a substrate. Enzymes can increase the reaction rates by enormous factors, 10 to the power 17, and tend to be very specific, typically producing only a single product in a quantitative yield. They are the focus of active research. They cease functioning at temperatures greater than 37 degrees centigrade. Enzymes are typically used in laundry detergents, and to tender the meat. Enzyme inhibitors cause a decrease in the reaction rate of an enzyme-catalyzed reaction. Thus catalysts are facilitators that help the chemical reaction to occur more quickly or under more favorable conditions. Once the reaction occurs, the catalysts still exist and can be used again in future reactions.